Hello everyone. Once again, I would like to welcome all the viewers, especially the class 10 student, to this online class. So to recall, in the previous class I have done about the concepts of acids, bases and salt, which is taken from the class 10 science textbook, which is prescribed by MBOSE. So today I am going to do about the chemical properties of acids and bases. We have different types of chemical properties of acids and bases. The first one will be the effects of acids and bases on common indicators. That is this one, effects of acids and bases on common indicators. I already explained in the previous class that what is an indicator. Indicators are those compounds which indicate or tell us the acidic or basic behavior. Alright. So in here we have different types of indicators. But for now, we list down only 4. The first one is phenolphthalein, methyl orange, litmus blue, and litmus red. So when we bring these indicators in contact with an acid or with a base, it will change its color. The first one is phenolphthalein. Phenolphthalein is colorless naturally. So when phenolphthalein comes in contact with an acid, it will turn colorless. It will remain colorless. But when a phenolphthalein comes in contact with a base, it will turn into pink color. Alright, then the next one is methyl orange. Methyl orange is reddish orange in color. When methyl orange comes in contact with an acid, it will change into pink color. But when methyl orange comes in contact with a base, it will change into yellow color. Right? Then the next one we have litmus blue. Litmus blue, when it comes in contact with an acid, it will turn into red color, but when it comes in contact with a base, it will turn into blue color. It will remain blue. The last one is litmus red. Litmus red, when it comes in contact with an acid, it will remain red color, but when it comes in contact with a base, it will turn into blue. To recall again, here we have phenolphthalein. When it comes in contact with an acid, it will turn into colorless. Again, phenolphthalein, when it comes in contact with a base, it will turn into pink color. Methyl orange, when it comes in contact with an acid, it will turn into pink. Methyl orange, when it comes in contact with a base, it will turn into yellow color. Litmus blue, when it comes in contact with an acid, it will turn into red. Litmus blue, when it comes in contact with a base, it will turn into blue. We have litmus red. When it comes in contact with an acid, it will remain red. But when it comes in contact with a base, it will turn into blue color. So these are few of the indicators. When they come in contact with an acid or a base, they bring some changes in their colors. This is the first chemical property of acids and bases. The next property will be how acids and bases react with metals. Alright, we'll do the second property, that is how do acids and bases react with metals. Alright, second property, how do acids and bases react with metals. Alright, so in this case, we are going to see what is the reaction of metals with acid or what is the reaction of metal with a base. Alright, so first we will do acid with metal. We already knew that acids contain hydrogen. Alright, so in this case, all those metals, when it comes in contact with an acid, it will displace hydrogen. Alright, it will displace hydrogen. Then that metal, in combination with the remaining of the acid, it will give a compound. That compound is called as metal salt. It means here, when you take the reaction of metal with an acid, you are going to get a salt and hydrogen, right? we have metal react with an acid, we will get salt, or we can say metal salt. We'll get metal salt and hydrogen. Right? So to understand this reaction very carefully, let me give some examples so that you can visualize it clearly. Let us take metal to be zinc in solid form. Zinc is the metal. Acid, let us take HCl, that is hydrochloric acid in aqueous solution. So what happened? When metal react with an acid, we are going to get metal salt with hydrogen. Alright, with hydrogen. So first, let me write first hydrogen. This is in the form of a gas, right? We will get H2. Here we have, this is the hydrogen. H2 there, we need 2. So we have to balance, we'll multiply here by 2. Alright, it's like these two get split. Alright, hydrogen is already displaced. What is left? Metal will combine with the remaining of the acid. So for metal, zinc will combine with chlorine. We'll get zinc chloride, that is ZnCl2. We'll have 2 chlorine because of this 2. Zinc chloride, this is in aqueous solution. This is zinc chloride. So this is one of the metal salt. Right? Same thing, you can react zinc with another acid. Let us take sulfuric acid. Zinc with sulfuric acid. Let's take H2SO4. Again, this is in aqueous. So what will we get? We get hydrogen. Sorry, this is plus. We'll get hydrogen in the form of a gas. So what happened? Hydrogen is taken out. Alright, this is one, H2. So what is left? Zinc will combine with the remaining of the acid. So we will get ZnSO4 in aqueous. So this is zinc sulfate. See? Alright, so these are the two examples. When you combine a metal with an acid, you are going to get metal salt with hydrogen. You can perform some more, right, by taking another metals with these acids. And now the next one, we will take metal with a base. Same thing will happen when you take a reaction of metal with a base. Again, there you will displace hydrogen and you are going to get a compound. So try to recall here, what is a base? A base is those compounds which are of the form of metal hydroxides and metal oxides, right? Metal hydroxides and metal oxides. So you think there a little bit. We have to react metal with a base. We already have metal there and the base also there is a metal. So it means when you combine, you are going to get two metals, right? Two metals, salt of two metal and with oxygen, and then you will get hydrogen. So what is the reaction of metal with a base? Reaction of metal with a base, you will get salt of two metals with oxygen plus hydrogen, right? Now metal will react with base, you will get salt of two metals with oxygen plus hydrogen. Right? Plus hydrogen. So this is the reaction of metal with a base. You are going to get salt of two metals with oxygen plus hydrogen. So let us take few examples in order to understand this very clearly. First, let me take again the metal to be zinc and solid. Base, let us take sodium hydroxide, NaOH. This is it, A2. So what will we get? Again from here it will displace hydrogen. You are going to get hydrogen in the form of a gas. Have a look from here. You are going to get hydrogen. This is hydrogen. You have only one. Then you need to balance, multiply it by 2. Alright. So hydrogen is already taken out. what will happen? Metal will combine with the remaining of the base. You are going to get, we have 2 sodium here, Na2, and then react with zinc, Zn, and again 2 O2, right? So this is the compound, right? We have salt of 2 metals with oxygen, and this salt is named as sodium silicate, right? Sodium silicate. Again, let me give another example by taking zinc with another base. Let us take potassium hydroxide, KOH. So what will we get from here? Again, we are going to get hydrogen, H2. Same thing, we have 2 hydrogen, but in this case it's only 1. Balance it, multiply by 2. So what happened? Hydrogen is taken out, we are left with metal with the remaining of the base. So we'll get K2ZnO2. This is in AQ. So this is the compound that we get. This compound is named as potassium silicate. This potassium silicate. Alright. So these are 2 of the examples in order to understand the reaction of metal with a base. You will get salt of 2 metals with oxygen with the hydrogen. Right? So now we will do the third property, and that is how do metal carbonates and metal hydrogen carbonates react with acids. The third chemical property is how do metal carbonates and metal carbonates react with an acid. Alright, so this is the third property, that is how do metal carbonates and metal carbonates metal hydrogen carbonates react with an acid. Right. The third property is this: how do metal carbonates and metal hydrogen carbonates react with an acid? Right. So we are going to see the reaction of metal carbonates with an acid and metal hydrogen carbonates with an acid. Here, metal carbonates and metal hydrogen carbonates, when they react with an acid, you are going to get salt, water and carbon dioxide. Alright, both the metal carbonates and metal hydrogen carbonates are going to give the same product, that is salt, water and carbon dioxide. Here, metal carbonates or metal hydrogen carbonates when they react with an acid, you are going to get salt, water and carbon dioxide. Right? So to understand this reaction very carefully, again I'll give you few examples. Let us react first metal carbonates with acid. You need to get salt, water and carbon dioxide. So metal carbonate, let's take sodium carbonate, Na2CO3, right? With an acid, you can take acid, hydrochloric acid, HCl, Then you need to get, this is an aqueous, you need to get salt, water and carbon dioxide. In order to understand very carefully or for you to visualize easily to balance, you can take first this one, carbon dioxide, this is in the form of a gas, and then water, H2O, in the form of a liquid. Carbon dioxide, CO2 is taken out, CO2, 2 oxygen is taken out from here, we are left with 1, so this is the 1 here, so all the oxygen is taken out, right? And then H is there, we have here H2O, but here you have only 1 H. What will you do? You balance it by multiplying here with 2. So now you will get H2O, 1 O is coming from here, and then carbon dioxide. So you react with the remaining one, we are left with Na2 with Cl2. So that is twice NaCl. This is the salt that you get, sodium chloride. Sodium chloride in aqueous solution. Right? So this is the first example. Alright. Now let me give another example. That is calcium carbonate, CaCO3 in aqueous. You will react with nitric acid, HNO3. Right? So here you will have carbon dioxide, water, right? Carbon dioxide, CO2. So 2 oxygen is taken, 1 is here, but here you have 2 hydrogen, you need to multiply here by 2, H2O is balanced. So what is left now? Calcium will react with nitric, with this nitrate, so we'll get CaNO3 whole thing 2. This is calcium nitrate, right? Calcium nitrate. So these two are the metal carbonate. Let me take another one, metal hydrogen carbonate, or we call metal bicarbonates. So let me take magnesium, HCO3 whole thing 2. So let me react this with sulfuric acid, H2SO4 in aqueous. Alright, we react magnesium bicarbonate with sulfuric acid. We need to get carbon dioxide, water, right? Carbon dioxide, water, that's it. Here we have 2 hydrogen, you get 4, but here we have only 2, you need to balance, multiply it by 2. And next we have 6 oxygen, 2 to 3, 6. Here we have 2, here only 2, we need 2 more, we'll multiply by 2. 2 to 2, 4, with this 2 we'll get 6. And then 2 carbon, so this is 1, right? So next we will combine the remaining magnesium sulfate, MgSO4. So this is magnesium sulfate. Right? So this is the reaction of metal bicarbonate with acid. You get salt, water and carbon. Right? So this is the third property, reaction of metal carbonates or metal hydrogen carbonate with an acid. You need to get salt, water and carbon dioxide. The last property is how do acids and bases react with each other. Alright, the fourth property is how do acids and bases react with each other. How do acids and bases react with each other. Right? So this is the fourth property. We are going to see how acids and bases will react with each other, or what will happen when acids and bases react with each other. Here, when acids and bases come and combine with each other, it will give salt and water as the only product. Alright, when acids and bases combine with each other, it will give salt and water as the only product. That reaction is also called as neutralization reaction. Alright, we have when the base combine with acid, we need to get salt and water. Alright, so we already know that base are the compounds which consist of metal hydroxides and metal oxides. Alright, so we are going to do it separately. First we'll do metal hydroxides with an acid and then metal oxide with an acid. The first one, metal hydroxide. With an acid, you are going to get salt and water. Alright. So in order to understand this, let me do by an example. Metal hydroxide, let us take sodium hydroxide and AOH. Alright. With an acid, we can take hydrochloric acid, HCl. This is in AQ. Then here you need to get salt and water, right? H2O in liquid. So what happened? One hydrogen from here is taken, with this two will get H2O. Then you will get NaCl. This is the salt which is known as sodium chloride. Right? So this is the reaction of metal hydroxide with an acid. You are going to get salt. In this case it is sodium chloride with water. Or you can take another metal hydroxide, that is potassium hydroxide, KOH. Take with acid. Let us take hydrochloric acid again. So you need to get water and salt. Alright. So same thing, it's already balanced. Then we are left with KCl. This is NaD. So this salt is known as potassium chloride. Potassium chloride. Alright. So this is the reaction of metal hydroxide with an acid. You will get salt and water. Then the next will take the reaction of metal oxide with an acid. We will get again salt and water. Second one. Right, the second one is metal oxide with acid. We will get salt and water. Alright. This is the second reaction. We'll take metal oxide with an acid, we'll get salt and water. So metal oxide, let us take lead oxide, PbO. This is in solid. Let us take lead oxide, PbO. This is in solid. Acid, let us take nitric acid, HNO3. Alright. Here we'll take lead oxide with nitric acid. We need to get salt and water. So here we need to have water, H2O. Hydrogen we'll get from here, but this is only one, we need to balance, multiply by 2, H2O. So we are left with PbNO3O3. So this is the salt that we get, that is lead nitrate. Lead nitrate. Right? In order to understand clearly, let me give some more example. Let us take another metal oxide, that is copper oxide, CuO. Right? Again, let us react with nitric acid. HNO3. So combination of copper oxide with nitric acid, we must get salt with water. Let's take first this water. Here 2 hydrogen, but here we have only 1. We need to balance, multiply it by 2. So we'll get, now we are left with copper nitrate, that is CuNO3 2. So this is the salt that we get here, that is copper nitrate. Right. So last example, let me take iron oxide, FeO. Let us take with hydrochloric acid, HCl. So what happened here? You need to react iron oxide with hydrochloric acid. We will get H2O liquid. So same thing, we need to balance, we'll multiply here by 2. So we are left with FeCl2. Thank you. Alright. So this is the salt we get here, it is iron chloride. Alright. Or we call ferric chloride. Right. So these are few of the examples when we react metal oxide with acid will get salt and water. Alright, so here we complete all the 4 properties of acids and bases. I believe you have understood all these properties. In order to understand very clearly, you can practice at home with some more examples. So we will stop here for today, and in the next class we will do the pH scale. Until that time, stay safe, take care.